Okay, back to that union concept. In your left pocket, you have a quarter, a paperclip, and a key. In your right pocket, you have a penny, a quarter, a pencil, and a marble. What is the set that represents the different items in your pocket? So a left pocket, quarter, paperclip, key. Right pocket, penny, quarter, pencil, marble. Write the union of the sets. So again, everything that's in both, quarter, paperclip, key, penny, pencil, marble. Notice we'll list the quarter once because we're looking for the type of item in that case. The type of item. Write sets P and Q below in roster form. What is P union Q? So in roster form, right, so it says P, X such that, remember that, X such that is a whole number less than 5. So 0, 1, 2, 3, 4. Set Q, Q, or Y, set Q, Y such that Y is an even natural number less than 5. So even natural less than 5. So it's just 2 and 4, right? So the union is going to be 0, 1, 2, 3, 4. All of the stuff in there. And then we want to know what is true about the union of two different sets if one set is a subset of the other. Well, the idea is if one's truly a subset of the other, then, as is the case here, then you're really just listing the universal set, right, or the one that it's part of. So the intersection of sets, X is natural numbers less than 19, Y is Y such that Y is an odd integer, and Z such that Z is a multiple of 6. So list the elements that are in both natural numbers less than 19 and multiples of 6. So X intersection Z, right? So 6, 12, 18. Again, the overlap. What is Y intersection Z? So list the elements that are in both sets. There are no multiples of 6 that are also odd, right? Can't be. In that set, let's say. So Y and Z are disjoint sets. We know that. So the null set or the empty set is their intersection, which we mentioned earlier. Alrighty. So let's set A, 2, 4, 6, 8. Set B, 0, 2, 5, 7, 8. And C, N, such that N is an odd whole number. Right? So an odd whole number like 1, 3, 5, 7, that sort of thing. Okay? So A intersection B. A intersection B is just going to be 2 and 8. The only overlap is 2 and 8. B, A intersection C, well, they're odd numbers in C, so there's no overlap there, right? So it's the null set. And C, what is C intersection B? Well, B is only goes up to 8. So 5 and 7 are the only odd whole numbers in B. So 5 and 7 is the intersection there. Right, now here's where it gets to the fun stuff. You can draw Venn diagrams for these things to help kind of keep track of what's in what. So when it says 3 friends are going camping, the items in each of their backpacks form a set. What items do all 3 friends have in common? So the friend with the yellow bag is a flashlight, sunglasses, pan, water, hat, and a map. The red bag has rope, water, hat, pan, or water, hat, map, first aid kit. The blue bag has water, hat, map, first aid kit, and camera. All 3 friends, so what are we looking for here? What do they have in common? That's the one they all intersect. So yellow intersect blue intersect red is water, hat, map. Okay, so you can draw a Venn diagram for this one, whatever works for you. Some folks find that useful. I'm going to list them out first, though. Set A is X such that X is one of the first 5 letters in the English alphabet. So set A is going to be A, B, C, D, and E. Right? And set B is X such that X is a vowel. So we're going to go A, E, I, O, U. No sometimes Y, none of that. I know you're thinking it. And set C is letters of the word vegetable. V, E, G, E, T, A, B, L, E. And you can put commas. I can put an extra comma over there just now. There we go. Alrighty. So you got to figure out what is in all 3 sets. Well, we obviously find out that we see an A and an E in all of them. Sometimes maybe more than one E, right? So an A and an E. So is what we're looking for. Again, you can draw it in a Venn diagram, however it makes you happy. Okay, so Venn diagrams do come in pretty useful at times. In this case, I'm going to show you how we can use it to decide how many folks take a certain mode of transportation. This is not unlike a question you'll see on my quiz or my test. So of the 500 commuters polled, some drive to work, some take public transportation, and some do both. 200 people drive to work, 125 use both types of transportation. Okay, so I do know that, 200 total drive. I've been told that 70, or 125 rather, do both. So that means between this, in this circle here, this blue, or this green circle, I'm sorry, the green should be 200. If 125 do both, that leaves 75 over that only drive. Okay? So that's how we get the first part of this. Now you got to think, we're going to be asked, obviously, number of commuters using public transportation. So if 200 fit here, right, and 500 were polled, we are left with 300, right, that in this part. So we know that we're left over 300 that use public only. So again, double check yourself as you go along. 300 plus 125 plus 75. That's my 500. The question asks, how many take public transportation? So they didn't say only public transportation, but take public transportation. So my 300 only plus my 125 that take both, those are the total people that take public transportation. So you get your 425 for public transportation total. Again, some of those do both. Okay, so let's read this carefully together first. Of 30 students in student government, 20 are honor students and 9 are officers and honor students. So this 9 is inside of that 20. All of the students are officers, honor students, or both. How many are, so that kind of leaves it, you can't say, oh, this kid's none of them, right? How many are officers but not honor students? So I'm going to come up with a Venn diagram, a little bit of overlap. I'm going to put honor students, officers. Now I do know from what it said here that 20 are honor students. Okay, so there's going to be 20 total in that circle. 20 total in that circle. 9 of those are both, so I put that 9 here. That leaves me with 11 that are only honor students. Now it wants to know how many are officers but not honor students. Well, there's 20 here, right? And we hold a total of 30, so that's going to leave us with 10 over here that are just officers. And add them up. Does that add up to 30? 9 plus 11 plus 10 is 30. Okay, so now we can apply this idea to absolute values. We've kind of been hinting at that. What are the solutions of 2x? The absolute value 2x minus 1 is less than 3. Write the solutions either union or intersection. So you got to think about what and or means, right? And is going to be your intersection piece, the overlap. Or is going to be your union. Okay? So our less than meant and, right? That was where you do the three-sided one. So that is going to obviously be, again, that's going to be the overlap between them, if we put it that way. The solutions of the inequality are given. Obviously, again, here, so we subtract the 1, right? So let's back up to make sure you remember. Absolute value of 2x minus 1 is less than 3. That's where you put the opposite on the left side, the actual number on the right side, and then we do a three-sided problem. So add your 1, divide your 2, so we know the answer is between -1 and 2. So we can write that compound inequality as an intersection because it's an and. So x such that x is greater than -1, right? And x such that x is less than 2. This is where it gets really thinky, folks. Really thinky. Look at the examples if you need it. Make sure you ask some questions. Okay, you ready? Now, A's already been written out as a three-sided problem. So, and again, you know that's an and. It's an intersection. It's an and, right? So in these symbols that we're using, the intersection and the union, are actually used in sentential and symbolic logic problems you'll see later on in college, or maybe even in high school still, depending how far you go. Let's go ahead and solve the A. Obviously, we're going to go ahead and we're going to subtract that 5 from all three sides, right? So we're going to have 3 is less than or equal to x less than or equal to 6. And again, writing that as an intersection, right? Write it as an intersection. We're going to have to write, well, let's break it back into the pieces it is first. We know it's x is greater than or equal to 3, and, there we go. And maybe that's not really the word and, it tried to be. And x is less than or equal to 6. So we can easily write that, and I'll bring that up here for you, as in set builder notation, right? So we say that as x such that x is greater than or equal to 3, and x such that x is less than 6. Let's take a look and solve B on that one. And on B, we have to, since this is an OR, right, it's a greater than, so it's an or it's going to be a union, another way to think about it. We had to write two problems. 4x minus 6 is less than negative 14, and we also write 4x minus 6 is greater than positive 14. So we've done this before, this is not new to you. So add your 6, right? And so we get 4x is less than, what do we got? Negative 8. Divide off the 4. And x is less than negative 2. And over here, we go ahead and add our 6 again. And 4x is greater than 20. Divide the 4, and x is greater than 5. So, obviously, these two don't have an overlap, right? Because you're less than negative 2 and you're greater than 5, so that's going to be the union piece. So if we wrote that out in set builder notation, we have x such that x is less than negative 2, and, right, the union, or said the wrong word, or x such that x is greater than 5. Got a union there.